So the question asks about a car that is moving in a circle, and the car has a velocity of an angular velocity specifically of 20 minus 1/2 multiplied by t squared, and this is in radians a second. The question wants to know at what time does this car reverse direction, and at what angle does the car turn between t is 0 and the instant which it just reverses direction. So here I have a picture of the car and how it is basically driving in a circle, and it is going to slow down and slow down until eventually it'll switch directions and go the other way. So here is a velocity versus time graph as the velocity starts out faster and then starts going down a lot faster um, with a t squared here. So the important ideas of this question include connecting calculus and physics. This is a physics problem which you basically need to use a little bit of calculus for. At least calculus makes it a lot easier to use um, to do the physics problem. And another big idea of this problem is the idea of rotational motion and how there's always a centripetal acceleration towards the center. Finally, one of the most important learning objectives here is that rotational motion basically follows the same equations as linear motion, except with new variables and new units. For example, distance can become radians. And here I said W is just like velocity in linear motion. So, in order to solve this problem, the first part, we need to set the velocity equal to 0, because when the velocity is equal to 0, that generally means that there is a change in direction, in position. So the position will go from positive to negative, um, and this is because velocity is switching from positive to negative. So here I solve for velocity being 0 by setting w to 0 and solving for t. So this allows me to find when t is the time in which the velocity is 0, and basically whenever the car switches um, from going forward to going backwards. So the other strategy we want to use for this problem is to integrate. And by integrating, we essentially are able to turn velocity into position. And once we turn velocity into position, we're able to find the total displacement for the problem. So doing this, I integrate from 0 and the time that we solved for before, in which the car would go the opposite direction. So at square root of 40 seconds. So put this into an integral, and we get this by finding the antiderivative using the fundamental theorem of calculus. We do this where we plug in square root 40 as the b bounds and 0 as the a bounds and subtract. And doing this, we basically get the net displacement. And we know since it's not turning directions, this is also like just kind of the distance in radians covered. And this equates up to be about 84 radians. Finally, one common mistake in this problem is that you do not realize the connection between the rotational motion equations and linear motion equations. The rotational motion basically uses very similar equations to linear motion, except the variables and the units are switched. For example, radians a second would kind of correspond to meters a second, and meters a second squared for acceleration would be like radians a second squared. So noticing this will really help you with this problem.